Okay, class. What I wanted to review with you quickly was the catecholamine pathway and just review the neurotransmitters, some of the major neurotransmitters. Keep in mind these neurotransmitters help to create either an excitatory postsynaptic potential or an inhibitory postsynaptic potential. And when you look here on the top left, you'll see it goes from phenylalanine to L-tyrosine. And you'll see that there's an enzyme that's required, phenylalanine hydroxylase enzyme. Anything that ends in ase is an enzyme. So phenylalanine hydroxylase enzyme. And in order for that enzyme to work, there are cofactors that are involved in making that work. It's kind of like having a gun with bullets, but unless someone actively pulls the trigger, a gun isn't going to hurt anyone. So you can have this enzyme that's available, but unless there are cofactors, which would be like someone pulling a trigger, the enzyme isn't going to do anything. So the cofactors are iron, niacin, tetrahydrobiopterin. That's needed to go from phenylalanine to L-tyrosine. And then L-tyrosine to L-dopa, you need another enzyme, tyrosine hydroxylase enzyme. And again, there's cofactors, iron, niacin, folic, the same exact cofactors. Then from tyrosine to L-dopa, you need P5P, which is pyridoxal 5-phosphate. That's really the bioavailable form of B6. Then L-dopa to dopamine, copper and vitamin C. Then dopamine to norepinephrine, SAMe, which is S-adenosylmethionine. That's where methylation is required. And we spoke earlier in the term about MTHFR, this genetic mutation where many people can't methylate. Then norepinephrine to epinephrine. Okay, you need that SAMe. So that first step, phenylalanine to tyrosine, there are people that can't make that initial conversion. And if you can't make tyrosine, you're not going to be able to make T4 and T3, right? Your thyroxine and triiodothyronine. So, very, very important step. And there are at times these genetic issues like PKU where people are born with the lack of phenylalanine hydroxylase enzyme, so they can't make that initial conversion. Major issue, because if you can't convert phenylalanine to L-tyrosine, the rest of that catecholamine pathway, dopamine to norepinephrine to epinephrine, can't take place. And if you can't make dopamine, these are people that get these migraines, these bad headaches. If you can't make norepinephrine and epinephrine, now you start to have these mood disorders where they're starting to get like antsy, or they have anxiety and they're anxious, and then they start having anger issues and anger management issues, and then the slightest thing can set them off. So there are people who don't have PKU, right, phenylketonuria, but through excessive diet products and diet soda and diet Sprite and diet, all the stuff with diet that have these artificial sweeteners can actually downregulate that initial step from phenylalanine to tyrosine. So it's almost like an induced PKU. And it's going to have the same effect. These are people that get these bad headaches, anxiety attacks, and panic attacks from using diet products and having the aspartame, a lot of these artificial sweeteners kick in. So major issue. In order to make these catecholamines, you need to have protein in the diet. Not only do you need protein, but you also need to have digestive enzymes to break down the protein, to get these amino acids, to get these neurotransmitters. So there's a lot involved there. And then just to review, the three precursors in order to make neurotransmitters, you need tryptophan in order to get serotonin and melatonin. You need tyrosine, which is the pathway I just showed you, tyrosine to L-dopa to dopamine, norepinephrine, epinephrine. You need tyrosine in order to get your thyroid hormone and melanin. And then on the right, number 3, you need glutamine. And from glutamine to glutamic acid, which is glutamate, and then glutamate is the accelerator and GABA is the brake. Okay? Glutamate should be high in the morning, GABA should be high at night. You don't want those reversals in those. We said with glutamic acid, when you get up in the morning, if you hit the snooze button, you're GABA dominant. At nighttime, when you should be sleeping, if you can't because there's too much brain activity, you're glutamate dominant. All right, so there's just a little review on those neurotransmitters.